Welcome to another episode of Keeping Up with ENGG 104. Today we'll be looking at Kirchhoff's voltage law in AC circuits. Kirchhoff's voltage law states that the sum of all voltages around any closed loop is zero. It originates from the law of conservation of energy and charge. The difference is that direct current only flows in a single and constant direction, whereas alternating current periodically reverses direction and changes magnitude. It is commonly used in household appliances. So does KVL apply to AC circuits? Well, yes, it does, because the law of conservation of energy applies to all circuits and ensures that the total energy supplied in a loop equals the total energy absorbed. Before we can understand how KVL is applied to AC circuits, there are some new terms that we must understand first. Impedance is how much a circuit resists alternating current. It's measured in ohms and is a complex number that combines resistance, which turns energy into heat, and reactance, which stores and releases energy. It also causes shifts in timing or phase between voltage and current. A phasor is a complex number representation of a sinusoidal signal, which captures both its amplitude and its phase. Phasors are used because AC voltages are often not in phase with each other. This makes it easier to analyze circuits using techniques such as KVL. KVL in AC circuits means that the alternating voltage in a loop is shared among the circuit elements, which are represented as phasors. Current and voltage in each element are linked by its impedance, the AC version of resistance, which depends on whether it's a resistor, inductor, or capacitor. By adding these phasors and using impedance in place of resistance in Ohm's law, we apply KVL in AC just like in DC, only with complex numbers instead of real ones. To review, KVL can be applied to AC circuits, and phasors are complex numbers that replace voltages. Impedance is the AC version of resistance, and KVL is the same as DC, however, it is the phasor voltages that sums to zero instead of the voltages. Until next time, and thank you for watching.